Welcome to the CyberSangha podcast. CyberSangha is a program of free live broadcasts, launched in 2009 by renowned teacher and author Tenzin Wangyal Rinpoche. Join us as we draw on ancient Tibetan wisdom to discover how to connect with our best self and live to our highest potential. The following conversation, Sleeping, Dreaming, and Well-Being, a Scientific and Spiritual Exploration of Sleep, Part 1, happened on April 30th, 2024, as a Science and Spirituality dialogue with Danny Lewin and Geshe Tenzin Wangyal. This was part of a year-long series of dialogues from 2024. This content is for informational purposes only. Listeners should consult medical professionals for any physical or mental health concerns. Please use headphones and do not meditate while driving or operating machinery.
So welcome everybody on this Facebook Live, and I wanted to welcome Dr. Danny Lewin, today's special guest. I'll do a little short introduction, and which is already also published in the CyberSangha website. So welcome. So Dr. Danny is licensed clinical psychologist, sleep medicine researcher, and clinician and pediatric psychologist. He was the founding director of behavioral sleep medicine and pulmonary behavioral medicine program at Children's National Hospital, and an associate professor of pediatric psychiatry at George Washington University School of Medicine. Danny served as a director of clinical sleep medicine at the National Institute of Health, National Center for Sleep Research. In addition to directing clinical sleep medicine program, he was director of an NIH-founded sleep research laboratory. Danny has published over 50 articles and chapters, and he's certified yoga teacher, meditation teacher, and psychedelic assisted psychotherapist. Sorry, and these are the new words. Sometimes I am having a hard time. So here, very, very welcome. And so I'm very, very happy to, Danny will do a PowerPoint presentation. And then after that, I will like to open, I have some few questions, then probably some more questions will arise as you speak. So welcome.
Thank you. Very honored to be here and with your community. You ready for me to begin? See that? All right. Well, greetings, everybody. Greetings, Tenzin Wangyal Rinpoche. Again, it's a deep, deep honor to be able to speak to your community and expand upon your wonderful advocacy for sleep health and better understanding of sleep. I want to just acknowledge the immense privilege that I have and many of us have for living in peaceful places. If you are in a peaceful place and not necessarily under threat, I live in this beautiful place where it was the unceded home of the Chumash peoples who inhabited these lands for tens of thousands of years. And then before them, I also just want to acknowledge the beauty of the flora and fauna, the animals that have inhabited this land for hundreds of thousands of years, and express my deep gratitude. So over the next 30 minutes, 40 minutes or so, And I welcome your questions, Tenzin Rinpoche. I'll give you a few definitions of sleep states and sleep stages, talk a little bit about what the meaning of sleep health is, and some of sleep's functions, and then try throughout to bridge a little bit some of the what we know in Western science about sleep, and have discovered, really interestingly, the field of sleep was really founded in the 1950s when rapid eye movement sleep was first discovered. And before that, sleep for millennia, at least in the West, was kind of considered as a time when we just shut down, parked in the garage and did little else. But as sleep has evolved in the past 6-7 decades or so, the findings of sleep, the brain, and consciousness, and what is actually going on, comes to the really the ancient practices and beliefs of Bon Buddhism, Tibetan Buddhism, and others who practice dream yoga. So the science is coming around and supporting some of the different conceptions of sleep. So I'll just define sleep initially, and this comes from our big textbook on sleep. And that's my little boy on the left. A few years back, about 20 some years ago. So sleep is a reversible behavioral state of perceptual disengagement from and unresponsiveness to the environment. It is also true that sleep is a complex amalgam of physiological and behavioral processes. And we all have certainly the subjective experience of sleep, but what I want to emphasize is, to a great extent, is that it really is an incredibly complex phenomena that impacts the body and brain and has a significant impact on our health. I know you can't read this, but these are the 75 or so defined sleep disorders. So there are sleep disorders that cut across behavioral problems, for example, insomnia, psychiatric problems, sleep and depression are closely linked, and PTSD are closely linked. Sleep-related breathing, snoring, which is not healthy, mouth breathing even, sleep apnea, neurological disorders of sleep-related movement disorders, parasomnias, where people get up in the middle of the night and act out different behaviors, circadian rhythm disorders, where your schedule is off relative to the demands of the environment. So it's really a complex field that has evolved tremendously over the past 60 years in defining disorders. The primary measurements of sleep, when we look at objective sleep during the night, are through electrodes that are placed on the brain. So it's EEG, electroencephalography, and this just represents just an example of how the brain changes throughout different sleep stages and wake stage. So here at the top, you see awake. And again, this is an EEG measuring brain activity, taking a broad average of brain activity at one region of the brain. And here you see a very, very fast random activity that's a mixture of theta, beta, even probably some gamma waves, very fast activity contributed to from regions really all over the brain. Then when we close our eyes and relax and begin to drift off to sleep, but before we fall asleep, there is this pattern called alpha activity, which is predominant in the posterior region in the back of the head. And that alpha activity then gradually decreases. And when there's less than a certain percentage of alpha activity in the brain, then we define sleep onset has occurred. Stage 1 sleep, which is the first stage of what we call non-rapid eye movement sleep, or NREM sleep, is, you can see in the EEG here, there's a slowing, so more white space here between some of these lines. There's an absence of alpha activity, and there's some of these other slower, much slower waves, and some of these sharp waves. So it's this transitional state, you can also call it a liminal state, where as we're falling asleep at the beginning of the night, if you were holding a ball and you were dropping off to sleep, you might be aware of your hand relaxing and you're dropping the ball, and you might startle awake. and have some explanation of what happened. Some people have this sleep start. They feel that they're falling. But what's important here in this liminal state is that we are kind of in and out of light sleep, and there's a lot of awareness of thinking, brain activity. We can have brief dreams during this stage of sleep. One of the newer conceptions, really in the past 15, 20 years or so, is that dreaming occurs and mentation, consciousness occurs periodically throughout the night. And I'll come back to that theme. That's a very, very important theme, particularly in considering relationships between sleep and dream yoga practices. So we spend about 1 to 3% of the night in stage 1 sleep. Stage 2 sleep then is about 50% of the night. And we know very little about slow wave sleep, except that some memory consolidation occurs during slow wave sleep and other activities as well. And it's characterized by these slow waves called sleep spindles, fast waves called sleep spindles, even slower waves called K complexes that serve various functions in the brain. Then the final stage of sleep, non-REM stage 3 sleep, is composed of these very slow, big, deep waves called delta waves. And so most of the top of the brain, and I'll show you some pictures of what goes on in the brain and body during these 2 final stages. This is the deepest phase of sleep. And I'll again go into more detail on that. And then rapid eye movement sleep is very fast, random. It almost looks like awake or a transitional state. And we used to call it paradoxical sleep because it looked like we woke up at some point in the night. And again, this was only discovered about 50, 60 years ago. So across the course of the night, we cycle in and out of these sleep stages. And that cycling changes across age. Typically, most adults have a sleep cycle of about 90 minutes or so. So this is time across the bottom axis here, 2200, 10 p.m., and then 8 a.m. on this side. And we go from wake to very quickly to a little bit of non-REM stage 1 sleep, a little bit of non-REM stage 2 sleep, and then we go very quickly into deep non-REM stage 3 sleep. And in that deep non-REM stage 3 sleep, we spend a good deal of time there. And then we cycle back up for a little bit of rapid eye movement sleep, back down to non-REM stage 3. So one of the important trends is that most of deep non-REM stage 3 sleep occurs in the first half of the night, or the first third of the night. There are changes across development in non-REM stage 3 sleep, not necessarily all that relevant, but that sleep decreases, at least these slow waves decrease in intensity as we age for a whole host of reasons. So then what you can see, the trend here that's very important, is that dreaming sleep, REM sleep, which stands for rapid eye movement sleep, increases over the course of the night. So by the end of the night, the predominant stage that we're having is rapid eye movement sleep. And this has various implications for how we perceive our sleep and what we do in our sleep. So just a couple more points here with this slide is that every time we cycle in and out of these stages, we have a brief awakening. We don't remember the vast majority of those awakenings, but we do have these little micro awakenings at least 20, 30 times a night. And then we might also have much longer awakenings, particularly in this region here, and I'll explain why that is the case in a little bit. But the quality, I should say not the quality as good or bad, but the qualitative nature of sleep shifts tremendously from the beginning of the night to the second half of the night. So a little bit more definitionally for stage 3 sleep, you can see here this is the EEG again, very slow waves. Children have a lot of deep sleep, and it's very powerful. You may remember that when your children were young, or if you have young children, that your child might fall asleep in the car seat or somewhere else in the house. You could carry them up to their crib, put them down, and they wouldn't budge. Because again, they're in this very, very deep stage of sleep. In the stage, we're passive, unresponsive to most environmental stimuli. There's a prevalence of parasympathetic influence, in other words, just the calm cycling of heart rate and digestive function and respiratory rate. And there's a quiescence of sympathetic activity, meaning that we're essentially not really responsive to the outside world and what activates us. The musculature is also deeply relaxed in this state. But what is important is that this state actually does contain some conscious activity. And certainly we can see that when we look at more fine-grained analyses, say like magnetic CT scanning, or people have looked at the brain activity during sleep, and they see different patterns of activity that show that there can be mental activity, brief dreams, during non-REM stage 3 sleep. These are relatively new and very exciting findings. And again, I'll touch on that a little bit more. So in the brain, during non-REM stage 3 sleep, this stage of sleep is initiated by serotonergic pathways deep in the brain from the reticular activating system in the thalamus. And then that initiates, there's impulses here that impulses activity at the level of the thalamus that then causes this broad synchronization, this slow firing of most of the cells in this top part of the brain, which is our thinking brain. And then there's deep inhibition of other regions of the brain and at the level of the thalamus that blocks incoming information, blocks some memory centers as well, and other types of awareness. I'll touch a little bit more on some of the qualitative nature of non-REM stage 3. In comparison, rapid eye movement sleep, dreaming sleep, this is when the majority of our long narrative dreams occur. You can see here is the EEG, very fast random EEG. These are electrical measurement of eye activity. And here you can see very organized eye movements, that when it goes in the opposite direction, the eyes are looking the same direction. And if you were dreaming that you were watching a fly, that actually tracks onto exactly how your eyes would move during rapid eye movement sleep. During rapid eye movement sleep, the vestibular system, the system that gives us awareness of sense of self in time and space, how we move through space, is activated. But many regions of the brain are also shut down. So during REM sleep, we perceive that we're active and have purposeful cognition, though we're non-responsive to most environmental stimuli, not all. You can certainly be, most of us, I think, have had the experience that we have a dream and we might hear something in the environment, and that enters our dream and shifts our dream. There's a variable balance between sympathetic and parasympathetic control, meaning that if we're having an upsetting dream, our heart rate might spike, our respiratory rate might spike, we might sweat, we might get very agitated or feel very agitated. During rapid eye movement sleep, there's a disconnection between the frontal control thinking part of the brain and the other parts of the brain in the body. So during the day, we might tell ourselves to take a deep breath. We might regulate our anxiety or hyper responsiveness. But during rapid eye movement sleep, that's shut down, so we can have much wider swings in heart rate and respiratory rate. Finally, and I think one of the more fascinating aspects of dreaming sleep is that we're paralyzed. So there is a broad atonia, loss of muscle tone in the periphery. You might see a baby, for example, twitching a lot as they're sleeping. And some people do have twitches. You might see your dog running in their sleep. And that is, they're still paralyzed, but there's a little bit of a breakthrough of activity. During rapid eye movement sleep, There's activation of the pontine nuclei deep in the brain stem, and then through cholinergic and glutaminergic pathways, it activates, it wakes up the brain. There's deep inhibition of the raphe nuclei and the locus coeruleus, which are related to serotonin, norepinephrine, so that in this stage of sleep, regions of the brain that are responding to emotion and experiencing emotion are heavily suppressed. So there's a quiescence, a sleep that's important for an important function of rapid eye movement sleep. When we don't get sufficient rapid eye movement sleep, or if we stay up all night, that feeling maybe in the morning hours that we're a little bit hyperactive or manic or activated is related to that loss of restfulness that occurs in these deep emotional regions of the brain. When people are sleep deprived for long periods of time, their emotion is much more variable. This can kindle a manic episode, can also be related to profound depression. So at the level of the thalamus, there and the thalamic-cortical pathway, the thalamus is one of the gatekeepers of outside information into the brain. There's desynchronization here of the top part of the brain. And then again, there's this deep activation, there's hyperpolarization of motor neurons that causes the atonia. All right, so that's most of the brain speak that I'll do. So I won't get into get into the neuroscience more unless there's specific questions. I'm not going to go deep into circadian rhythms because I think you'll have a talk in the next few weeks or a month on circadian rhythms. I'll just say a couple of things very quickly by way of introduction, because really the movement in the sleep field right now is that you can't really say sleep without circadian. They're essential co-functions of what goes on during the day and night. So back in 2017, the Nobel Prize in Physiology and Medicine went to 3 researchers who about 10 or 15 years before had identified clock genes. So if you think about the implication, what does it mean to have clock genes? Well, it means that every cell in the body, heart, lung, liver, eyes, skin, brain, have clock. So they're all running on their own individual clocks. And those clocks regulate, as you can see in this cartoon here, a whole host of different functions at different times during the day and night. So the simple take-home message for us around clocks is that it's not just how much we sleep that's absolutely critical, but it's also when we sleep that's absolutely critical. On understanding your individual sleep need, how much you sleep, and your clock time is also very important. So this is about as complicated as it'll get. I just have a couple of points that I want to share in this slide. This shows the relationship between the sleep drive that drives us into deep sleep and the other stages of sleep, and process C, the circadian system, which again is regulating tens of thousands of different functions across the body and brain. Here I'm just showing you the alerting signal. So again, we have time across this bottom axis here. This is 9 a.m., 9 p.m. This dark shaded line here is the sleep period. So when we go to bed at night, our sleep load is very high. When we wake up in the morning, our sleep load is low, and it gradually increases over the course of the day. So we have this high sleep drive, which is due in part to the buildup of a neurotransmitter called adenosine. And when adenosine is very prominent, we get tired. One of the most potent blockers of adenosine is caffeine. So it's one of the reasons why it's very important to stay away from caffeine at night and in the evening hours. So then once we fall asleep, our sleep drive or sleep load, or I like to call it the sleep appetite, our appetite for sleep, decreases very rapidly until it's almost gone in the early morning hours. So what's interesting is that around 3 a.m., 4 a.m., our sleep appetite gets exceedingly low. So the other system, the circadian alerting system, creates kind of hyper awareness during the day, increases, and interestingly, right before we fall asleep at night, we have this burst and activation. There are different names for that. You can call it the burst zone. That's the name that I like. It's a period of time, just as you're going to sleep at night, you might be aware of, oh, I'm so tired, I'm really ready to tuck in. And then you think, oh, well, I'm going to check my email one more time, or I'm going to check the news or do a little bit more work. You get this burst of activation, not sure why, you just don't feel tired. And then you start engaging in all of these other activities that are not optimal for going to sleep. So that is a phenomenon that actually is regulated by the circadian system. Children, you might be aware, young children, as they're going to sleep at night, can get wild at bedtime. All of a sudden, you're kind of working toward calmness. They get wild. They start running around, jumping on their bed, engaging with their siblings, perhaps. And that's also due to this burst zone, this activation that we think is probably related a bit to evolutionary history and our need to assure that the perimeters of where we are safe, that we have this burst of activation, this burst of focus to look around and know what's around us so that we can then tuck in for 8 or so hours into a very highly vulnerable state. If you imagine our ancestors living on the savannah in very poorly constructed homes, and many people today obviously living in war zones and in places where they don't have adequate housing or beds, have this need for this activation before they go to sleep at night. For people with anxiety, depression, PTSD, if you're very worried about your finances or something else, this burst zone can also get you very, very activated. And this is one of the probable causes of insomnia, difficulty falling asleep, and ultimately staying asleep. So there's a fall off in the alerting signal, a very significant fall off, and that is almost absent completely around 3 to 4 a.m. Our core body temperature also falls off during that time. And so if your sleep is well coordinated time-wise, then what should happen is that there should be a convergence of this low sleep appetite, because we've already slept for 4 or 5 hours, and this low alerting signal. And together, those help us reinitiate sleep for the second half of the night, which you may recall is predominantly rapid eye movement sleep. So again, I want to make the point here that it used to be called first sleep. The qualitative nature is very deep. We feel out of it. It feels very restorative. Normal to have an awakening at this shift point here when our sleep appetite is low. Some people wake up for longer periods of time. There are actually different studies of different cultures show that people say who live around the equator, who are more hunter-gatherer type cultures, they'll go to bed very, very late at night, sleep for 4 hours, wake up at maybe 6, 7 a.m., 5 a.m. before the sun rises, perhaps, get up, go do whatever activities. If they have cattle, or they'll go they'll hunt, they'll gather, they'll do what they need to do. And then it's too hot for them at midday. So then they'll sleep for 3 to 4 hours during the day, wake up again in the afternoon. So their sleep is biphasic. Some people also have biphasic sleep. They might wake up for 3 to 4 hours here, do some work, go back to sleep for a few hours in the morning, if their work schedule affords them that luxury. So again, that we have actually a lot of flexibility as human beings in terms of our sleep schedules. Yet we need to stick to a schedule, right? So if you're culturally sleeping in one way, and that's the way you have always slept, that's fine. There's flexibility, but you don't want to move from night to night from a hunter-gatherer sleep type to a ultra-Western sleep type where you're crossing 5 time zones. That's problematic. So second sleep, first sleep, again, that very deep sleep. Second sleep is much lighter sleep with a lot more rapid eye movement sleep, or we perceive it as lighter. We're in and out of sleep a lot. And some people will report they don't know that it's normal to wake up in the middle of the night. Very important to tell yourself that, right? Okay, it's one of the first messages for people with insomnia. that it's normal to wake up. So if you wake up in the middle of the night, and it's confirmation that you're a human being, and it's okay. And actually, there's a lot in Tenzin Rinpoche's book, Tibetan Yoga of Sleep and Dreams, about these awakenings and how to manage them. And then second sleep, again, feels much lighter. So some people perceive themselves not to even be asleep in the second half of the night, which is a form of insomnia also, when you perceive yourself not to be sleeping, when in fact, if you were in the sleep lab, you would be sleeping. All right, so I'm going to move on and just touch for a moment on this region of the brain that's received a lot of attention recently, called the default mode network, just to illustrate a little bit more about what happens when we sleep at night. And I think this has a lot to do with our perceptions of sleep and what's going on with our ego and other regions during sleep. So the default mode network is a distributed region of the brain. So it has kind of a hub, but it has many connections to other regions of the brain. It's active during periods of relaxed wakefulness, introspection, judgment of others. It is active during daydreaming. Michael Pollan, who has written on psychedelics, also written extensively on nutrition and on food, amazing writer, calls this region the address of the ego in the brain. And during sleep, I'll just show you what happens with the default mode network during sleep. During intensively focused meditation, rather than becoming more active, the default mode network actually quiets and shuts down some. So again, self-referential behavior, moral reasoning, recollection of and imagining our future, cognitive processes, judging ourselves, negative thoughts, worry about our future, all are related to activation of the default mode network. So just briefly, this shows some of the key regions of the default mode network. This is medial frontal cortex. This is the back of the brain. So what essentially happens during deep sleep is there's a disconnection between the frontal part of the brain, the thinking part of the brain, and the back or deeper part of the brain during deep sleep, which accounts for some of the suppression of thoughts and some of what we experience and some of the other activity during deep sleep. This shows connectivity, far too complicated for me. I am not a neuroscientist, but I just like this picture because it shows how much connectivity with the default mode network changes throughout the night. So this is light sleep, and you might imagine that during waking hours, if we're worrying about ourselves, all of these connections would be thick and dark. The lighter connections here are just that, lighter connections. But you can see that there's a lot that drops out going from light non-REM sleep to deep non-REM sleep. And then there are also significant changes when we go into dreaming sleep. Okay, so I'm going to talk a little bit now more about some of the clinical or the important health aspects of sleep. Again, if you have questions, Tenzin Rinpoche, don't hesitate to jump in. There's during sleep, some of the top functions are repair and regeneration of body tissue. And interestingly, the functions of deep sleep, the functions of stage 2 sleep, and the functions of the circadian system all contribute differentially. So circadian controls some of these factors, deep sleep controls some of these factors. It's a very complexly integrated system. We found recently very exciting finding that has significant implications for Alzheimer's disease and perhaps other brain degenerative disorders, that there's literally a washing of the brain during sleep. And this occurs in the lymphatic system, where we see cerebral spinal fluid and other liquid matter in the brain that literally gets rid of all the dead cells, problematic connections between cells, So this washing of the brain is essential, and there appears to be some association between Alzheimer's disease and insufficient sleep. And we think that this may be the case, that there's insufficient nightly cleaning of the brain. Very, very important system. There's consolidation of memory and learning during different phases of sleep. A complex and beautiful scientific literature that shows that REM sleep and slow wave sleep have different functions for different kinds of memory consolidation. That feeling in the morning when you wake up, or maybe in the middle of the night, and you wake up and you all of a sudden have this aha realization it can be as simple as, I'm so glad I didn't push send on that email, to a realization of, oh my gosh, I've solved this physics problem that I've been working on forever. So it's an indication that our brain is extremely active at night. It's problem solving, engaging, creative problem solving. Memory consolidation occurs. It's unclear whether memory consolidation occurring is simply a function of it's an underlying function and a strengthening function of the brain, or whether it's related to our thinking also during sleep. Again, this is a beautiful and emerging scientific literature. There's calibration of immune and metabolic function. In other words, our immune function is dependent on getting adequate sleep. Simple studies have shown that when you get a vaccine, the responsiveness to the vaccine is optimized when you get sufficient sleep at night. And that's in part because your immune system is processing at night. Same with your metabolic system. Our metabolism is dependent on certain changes that occur during sleep. There's calibration of neuronal brain cell activity, electrical chemical activity during sleep. So during the day, when we're being bombarded by tens of thousands of stimuli that we might be aware of or respond to moment to moment, there needs to be a recalibration. We think there needs to be a recalibration at night, and some of those slow waves may serve to do that. So a few basic tips around sleep. And again, I want to acknowledge Tenzin Rinpoche for his always talking about sleep health and optimal sleep. And I think that this repeats much of what he says, maybe adds a little bit, or I may be missing something, so please jump in with it. So really, and this is kind of evolved in my reading of his work over the years, that we really need to sanctify our sleep. We need to treat it as this beautiful, important, holy period of the night. And instead of calling what we do in preparation for sleep routine, really shifting the verbiage to ritual, that what we're really engaging in at night are rituals in preparation for our going into this period of our life that we do every night. And then the bedroom, is developing the bedroom as your sanctified space is also so important. It creates safety, it creates ritual, it creates habit. And in reading of the yogas of dream and sleep, there's a lot more that this kind of preparation and treatment of sleep facilitates. So quiet and together time before bedtime is also very important. Social engagement is critical. Having worked with children for decades, the closeness between parents and children, this is a very delicate, very intimate time, a time when a child first separates, experiences separation from their parent, and their parent first experiences separation from their child when we fall off to sleep. So making sure that the emotional milieu and the caring between parent and child is present, and it's important for all of us as well. You may notice that you sleep, unless your partner snores or has a movement disorder during sleep, you may find that you sleep much better when you're with someone. And really, throughout all of human history, we've slept together. We slept together in caves. We've slept together. Many cultures have sleeping rooms for men versus women. I would say we still sleep in caves. Now, for some of us at least, our caves just have multiple rooms, but we're still sleeping in a larger cave. And that social engagement around sleep is very important. regular timing and duration of the sleep period that matches your personal needs. So again, the duration of sleep that you need may differ from someone else. Some people really need 8.5 hours of sleep at night to be satisfied. Adults I'm talking about. Whereas others sleep fine and get adequate sleep if they're sleeping 6.5 to 7 hours a night. If you sleep a lot more than 9 on a regular basis or a lot less than 6 on a regular basis, that's associated with maybe some negative health markers that you might want to be aware of. And then the timing of your sleep is also important. This is a circadian factor that some of us are owls. We like to go to bed late and wake up late. Some of us are larks. We like to go to bed early and wake up early. And so knowing your chronotype is very important. So understanding the qualitative experience of sleep, that it changes throughout the night, is also important. So not expecting that the first half of the night is going to feel the same as the second half of the night. Regulation of diet and caffeine. You don't want to eat a big heavy meal before sleep, or even a big heavy meal in the evening. The European versus the American model, and I don't know what other country is, of a heavier meal midday, perhaps a nap, and then a very light meal in the evening is possibly much healthier for your sleep. Certainly, there's now a lot of evidence that periods of fasting have a critical importance on your sleep and on your gut health, your circadian rhythms, etc. Very important. Caffeine has a very long half-life, which means it stays in your body a long time. So if you have any trouble staying asleep at night, it's really best to eliminate any caffeine use, say after noon. It varies by person. There are those rare people who say, I go to sleep much better after I've had a latte. I would argue that there's a blockage of adenosine, and it's probably not good for their sleep continuity if I had the ability to measure what was going on in their brain. But generally, caffeine is activating, blocks adenosine, that good neurotransmitter that helps us sleep. So try to stay away from that in the late afternoon. No electronic media or bright light within 60 minutes of bedtime, both in terms of its being emotionally activating, and then light also shuts down a region of the brain that helps us initiate sleep. So we really want to eliminate bright light in the beginning of the night and in the middle of the night as well. Keep it dim, keep it amber colored, not blue or white colored. Establish a comfortable and now we'd say sanctified sleep environment. Address sleep problems. So if you snore or have restless sleep or excessive daytime sleepiness, those are all signs of a significant sleep problem that needs to be addressed. Clear your traces of your waking concerns before going to sleep at night. And this I borrow from the Tibetan yogas of sleep and dreams, and bring intention to your sleep. Go to sleep with some ideas about what you want to accomplish, and just wanting to accomplish a restful period and viewing sleep positively is important. Okay. So just a few findings that I think are particularly relevant and important and interesting in our sleep. That have occurred in the science recently, do we explore possibility and potential in the vacuum of dreams? So in other words, one of the functions we think of dreams is that they allow us to explore possibility that we could not explore during the day because we're shut off. We're living in our own vacuum, and we can fly, we can do anything during sleep. And there's some evidence that exploration of potential and option is a very important function of dreaming sleep. Does sleep have different roles across the lifespan? Absolutely. Different for children, middle-aged people, and elderly people as well. But it's still important for all. What are the sleep stages specific changes in consciousness and awareness? We're learning more about, there's a researcher who lives in Australia, Jennifer Wind, who does amazing work. She's a philosopher and has some background in neuroscience and looks at consciousness in the brain. She believes that sleep is a window into understanding more about consciousness and awareness. Regions of the brain sleep during the day, and regions of the brain are awake at night. So there's a recent finding that sleep is a local phenomena. So you can be going through periods of the day and different regions of the brain will fall asleep. And this was related to insufficient sleep over the past 24 hours. But it's also fascinating that regions of the brain actually wake up at night also, and that we have more mentation than we perceive during the night. Sleep facilitates neuroplasticity. We now know that permanent changes to the brain are facilitated by sleep. I talked about the default mode network. There are different shifts in the default mode network, the salience network, which kind of gives us context in our daily activity, the executive function network that tells a lot of the deep, rich stories and thinking processes, more of our cognitive work. Those all disconnect and have different types of activation and deactivation during sleep. And then finally, our dreams and hypnagogic states. Hypnagogic states are really very intense dreams as you're falling asleep at night. Some people have those, some people have not. Liminal states, light transitional states, and parasomnias, which include sleepwalking and sleep terrors, are these special cases for understanding conscious awareness, and these are being studied now. So I just did, just for the sake of perhaps discussion, I did just this very quick table to kind of make some comparisons between Tibetan Buddhist and yoga of sleep and dreams practices versus Western practices and how they might map on to different sleep stages. And this is not scientific. These are just some general ideas based on my reading that, again, we can discuss more. For some of these, we go into 2 and 3, which are very deep stages where we're not aware, although we can cultivate awareness during those states. During samsaric sleep, to a great extent during rapid eye movement sleep, and some of the dreams during non-rapid eye movement sleep. There is no correlate that we understand at all to clear light sleep in Western science at all. And this is something, as I'll say briefly, I think can be studied. There is also the study of transitional and liminal states, sleepwalking, daydreaming, I think is very interesting. And then meditation kind of falls in this area. There have been some wonderful studies of the brain of meditators. So I think this is my second to last slide, but I think some of the questions and overlaps that I think are particularly important that I think science can partner with. There's been, as I just said, partnership. Richie Davidson has worked with Tibetan lamas and other meditators to study what's going on in the brain during these states, to understand more about the health and other implications and about consciousness. How do consciousness and awareness change during sleep and wake states? How does lucidity during sleep and dream states inform our understanding of awareness? How can we harness lucidity? And finally, in the yoga of sleep and dreams, can we look at non-practitioners versus novices versus lifelong practitioners and see differences in how they sleep and what the nature of sleep is? So I'll close there with my sleep chatter. I'll just reintroduce my son, who's an important part of my talk always. And I thank you deeply for your attention and for your interest.
Thank you so much. That was wonderful. A lot of I have to go back and look at again and trying to understand everything. So I have few questions. I think probably I will be kind of going all over, but not very organized. But I will maybe one more simple question, and then maybe some little bit more complicated ones. So one, this question about so wake and your drowsy, and then you have N1, N2, N3, then you have REM. So these different stages that, as you explained in a slideshow, that 90-minute cycle, that first half of the night, if you think about 10 to 8 or something, then second half of the night you have more REM, hardly much deep, or in the first half of the night hardly much REM, but more deep. So, and then, so people like you're talking about the hunters and, in the old time evolution sense, but in a modern society, shift workers. Because the question is, some people, let's say if somebody comes back 12:30 and goes to bed one every day for years. So what about these people's deep sleep?
So great question. So shift workers, unfortunately, are at much increased risk of health problems. So there have been multiple studies done. There's a study on the nurses' health study where they looked at 10,000 nurses, those who did shift work and those who didn't do shift work. Those who did shift work meant that they were sleeping at times that were not optimal, right? They were sleeping during the day, and they were awake working at night. And the cost to them physiologically was significantly high. You had higher rates of breast cancer. Cancer, in fact, shift work has been deemed by the United Nations Center on Cancer as a carcinogen. So shift work is not a healthy phenomenon. So for those of you who do shift work, have to do shift work, deep gratitude, because there is sacrifice associated with that. But as our sleep, and I think this was also your question, as sleep changes, we catch up. So if you're traveling from California to Germany, for example, your sleep timing will gradually shift. So we have flexibility. Your circadian timing will shift, but you'll lose a certain amount of sleep associated with kind of the optimal functioning of your sleep. Your sleep pressure for deep sleep may spike and go very high when you're a little bit sleep deprived. They have done selective sleep deprivation studies where they deprive people of deep sleep, and over time that makes people sick. If you deprive people completely of sleep for 2 weeks or more, they die. So you can last, interestingly, as long without food as you can without sleep. Rapid eye movement sleep, it's very hard to suppress, interestingly, dreaming sleep. And if you try to suppress dreaming sleep, you'll get an interruption of dreaming. Dreaming will just come into your daily life in a very, very powerful way. You'll have hypnagogic waking dreams that seem very, very real. So our brains and bodies are great in helping us catch up when we give ourselves the opportunity to catch up. A few days of bad sleep.
So what about, like earlier you were talking about hunter-gatherer, people who did not have a shift work, but they did have a very specific routine, and that routine was pretty much maintain a big portion of their life. So because whatever they're doing, it's not like they're changing like me traveling different places, but they have a rhythm there. So you think they would have also kind of similar issues, or modern shift work have a more problem?
Modern shift work would have more problem because for a couple of reasons. One is because it's irregular. So they'll do, say, 3 12-hour shifts overnight, and then they'll go back to their day schedule. So that's problematic. Whereas other cultures who have a biphasic nocturnal and diurnal night and day sleep period will be very regular. They're still having their primary sleep during the dark phase, which is very, very important, and having some of their other sleep during the light phase. But it appears that there can be differences in how different people's sleep drive works. Actually, a good thing, right? If you have a small village, or imagine a herd of sheep or antelope out on the savannah or field, you don't want them all sleeping at the same time. And then in the same way, because then they'd be much more vulnerable to predators. So we've evolved with this flexibility and individual difference. But
they call hemispheric sleep. Yeah. The bird, part of the brain sleeping and another part of the brain is awake because they have to protect the birds.
Fascinating research, yes.
Yeah. Another question is, like, as in the end of the slide, you were comparing a little bit about the Tibetan tradition and the science here. So, as you know, in some sense, in Tibetan tradition, there's a dream yoga and there's a sleep yoga. So there's a two thing, which is deep and REM, I guess. And then in sleep yoga, sometimes they do talk about in a way like a 4 stages or something like that, because when they would in meditation they would visualize a paddle with the 4 different sphere of light in their heart, and these they will trying to focus on the first in the front direction, eastern direction, and then they will slowly, as they will go deeper, as you begin to fall asleep, you're trying to maintain some degree of awareness. So it's like a wake, deeper than that, and then the deepest one or something like that. They have specific names for them, but idea is somehow the ability to maintain some degree of awareness, as far as in the West, so like and 3, in a deep sense, there's awareness there. But basically the question is N3.
There is now evidence that comes from some labs, and Jennifer Wint summarizes this work beautifully, that there actually is mentation, there is mental activity during deep sleep. I think one way of thinking about this, and there are a lot of semantic disagreements around this, but if you think about the difference between awareness and consciousness, deep philosophical questions, awareness maybe is the ability to reflect on consciousness. Consciousness may be this large swath of mental activity and activity or environment that comes together. That during that there's continuity of consciousness throughout the night, but our awareness drops in and out. So we become aware variably of the conscious activity, and that definitely does occur during non-REM stage 3 sleep. And so some of the practices in preparation for sleep in your tradition, I think are very, very important for maximizing and optimizing some of the mental activity during non-REM stage 3 deep sleep.
Yeah. So one of the personal story, when I was flying to Europe, I hardly slept at all on the plane. When I got here, and then trying to function normally, but then the night after I slept 11 hours. So like almost like a dead. So what happens during those times? Like it's kind of in terms of the REM and deep, it's all over or something.
So yeah, so they adjust beautifully. The brain is so attuned to deficits in different stages of sleep that the brain helps us catch up. And not only did it give you a lot more sleep, but it also probably gave you greater electrical intensity of slow wave sleep. So maybe your slow waves were a little bit bigger. It may also be that you were sleeping at a time that was optimal for your West Coast schedule or wherever you were traveling from. So that kind of dead feeling of dead sleep was possibly related both to sleep deprivation, but also to when you were sleeping and how your body was adjusting to different time schedules.
Wow. Yeah, it's very interesting. I probably have many, many more questions, but I'm not sure. So I guess one of the thing is, it seems like, from your opinion, like as sleep is so important for well-being, every sense of well-being, physical well-being, mental, memory consolidation, as you listed all the physical health aspect. How is possible to bring some awareness in this world, including our own family members?
Yeah, it's such an important question. And, I again appreciate, a leader, like you and a teacher like you and a spiritual guide like you who advocates for healthy sleep. You do that so clearly and eloquently and hit all the key points. We know a lot about we know a lot about nutrition, and we prioritize our nutrition, we prioritize exercise, but sleep is also a pillar of health, and improving awareness of sleep health is really, really critical. Hopefully, I have a book coming out in the next year or so on family sleep health that will help promote, but we all need to promote that, the importance of sleep for all of our health.
Wonderful, wonderful. So, well, I'm sure probably, let's see, what time is it? Okay, maybe we can go on a little bit. So, anything you wanted to say, anything you wanted to share?
I think that what we're learning more and more, and I said this at the very beginning, is that we have a lot to learn in the scientific community from other cultures' conceptions of sleep and how sleep is practiced. And I think the idea that that the science has moved more and more to, and even interest in lucid dreaming has moved from a scientific perspective. I know one of your colleagues at Northwestern has studied lucid dreaming, and has basically shown that you can engage people. They train people to look different directions during dreaming sleep, and to facilitate lucid dreaming. They also have shown how during deep sleep you can actually engage people mentally during deep sleep, and trigger certain memories, and even maximize memory activation. That when there's stimulation, say smell sensation, that's coupled with something that you need to learn, and that's reintegrated during deep sleep, learning occurs. So
what will be from the scientific Western scientific point of view about during the REM sleep? When you have a lucid dream, what is any benefit, or any reason why we should have a lucid dream? Any benefit of it? I mean, Stephen Labarge, he was talking about that people who I think, if I remember correct, in his book, that people who have a lucid dream and who cannot walk, and then they start to walk in a lucid dream, and then the process of recovery, healing has speeded up, or people who have fear of public speaking or something like that. So in a dream, when they're exercising, rehearsing, and doing it, and then they're able to overcome their fears or something like that. Other than that, any other things that from Western perspective of lucid dream? I mean, from neuroscience.
Yeah, it's a great question. I think it's a very, very new and open field. I don't know. I think it's a really great question, and we need to test more about how you cultivate lucid dreaming effectively, and then the impact that lucid dreaming has, as you say in your books, and in your teachings, the potential to explore anything in the world during dreaming sleep, and learning how to engage dream yoga, and lucid dreaming, I guess, are pretty similar. Has wonderful potential to improve awareness, but those are open questions. That's ancient wisdom that we're coming toward, hopefully, in science.
Yeah, wonderful. Yeah, I was lately, I've been thinking a little bit about this, experimenting a little bit myself also, like of course, people will talk about breathing, like James Nestor will talk about the slow breathing, trying to put you into sleep, raising your HRV, and so on. But I was thinking that maybe as this sensation you were talking about last time, we were talking about sensation of falling down, like when you're going to sleep, in some sense, it seems like that's important to actually, in order to follow sleep, you have to kind of fall down. You have to let it go, your body. You have to let your pain body go, your pain identity go, pain stories go. So somehow, how to find a way to speed up so that you were actually able to let them go through your breath and meditation, speed up, or even the idea of surrendering, idea of not holding on whatever the thoughts, emotions are, surrendering those thoughts and emotion, and feeling, trusting completely fell down and falling down faster. So I think it seems like a much more fun.
How would you guide people and the broad population to achieve that degree of letting go and awareness?
No, I mean, generally, through meditation, we have many different meditations about basically the dissolution of the body and ego. Dissolution of the body and ego. There are many meditations, right? In awakened state. But I was trying to experiment some of those meditation that we teach during the daytime, really trying to amplify them as a process of going to sleep. So basically, you are. For example, 80% of the insomnia is based on anxiety. So the anxiety is sometimes very physical. So the physical means that whatever your thoughts and emotion, there's triggers of thoughts and emotion, whatever it is, somehow in some way in your body you're carrying it. So idea will be to you imagine your body in the middle of the sky or something, and then you are like this is what I've been having fun playing with it. So just imagine you're up in the sky, in the middle of the sky, infinite unbounded space, where you basically bring your attention to your body and let body dissolve, like imagining like ice, like the warmth of the sun hits the ice, and ice is melting into the ocean, and trusting that dissolution. And when you feel you allow it to dissolve, when you feel some sense your body, you don't have no longer a body, and then that the sensation of no body into that deep sleep, combining kind of the right timing, it feels like a very, very good feeling.
Beautiful.
Anyway.
Yeah. If you have the means to put something out to teach people that image, I think that it would benefit people, worldwide, and improve their sleep and transition to sleep.
Yes, absolutely. I know. I mean, I'm trying to doing a lot of personal self-experimenting, a lot of things, and then of course there's something I feel works for me, might work for other people, some people it might. So it's constantly a self-experimenting and sharing and talking. People like you who have a lot of knowledge background in these fields. So it's just fun journey. Well, Danny, thank you so much. Really appreciate your coming, and we will have these dialogues continuously. I think at the end of the May we have another one coming on, particularly on a circadian rhythm. So we'll continue. So share more information on our CyberSangha website, upcoming events. So thank you very much again. Take care.
Thank you.
Thank you for listening to the CyberSangha podcast. If you'd like to learn more about CyberSangha, visit us online at cybersangha.net.